Okay, so this problem is going to look at the effective forward head posture and just basic sitting posture. So the first thing we have to do is in seated, and here's we see a cervical spine and the outline of a skull on an x-ray. We have to locate the center of mass of the head, and then we have to choose an axis point to calculate the muscle activity around. So basically most people locate the axis point slightly anterior to the tragus of the ear. So this is the approximate location of the internal auditory meatus. And so then if we put the axis, the weight of the head here, the center of mass of the head here, we know that it's acting down here. And so that's the force of the head. Then the axis here, we have lots of different choices. And so just for convenience, we're going to count down the vertebrae and locate the axis here and calculate it at C7. So we know this is the C1 spinous process here. So we can count them out. We can put 1, 2, 3, 4, 5, 6, and then the biggest one, 7. Here we see that, and so this is 7. So we could basically put the axis point here at the C6, 7 vertebrae, and we know that that goes through the intervertebral disc, and so that could be our axis point. And so if we kind of project the external load down here, we know that the moment arm here of the external load is acting to flex the cervical spine, and so that has a, let's start that moment arm at 8 centimeters, and then we know that internally we have one of the more prominent muscles running up here between this superior and inferior nuchal lines is the extensor, the semispinalis capitis muscle, which is a key extensor of the head and neck. And so we could put here F, semispinalis capitis, and we could project it down here, and then we'd have its moment arm here. So basically we could do a moment equation here like this. We could put on something like this. We could say EM equals IM, where we have the force of the head times the moment arm at C7, and then all of that equals the internal moment, which is going to be FSC times the moment arm of SC at C7. Okay, and so essentially if we plug it in, it's going to look something like this. The weight of the head is around 40 newtons, so we can put 40 newtons times a moment arm of 8 centimeters. And for now, we're just going to focus on the external moment and project out what we think the internal forces change. And so basically this gives us a kind of total of 320 newtons per centimeter. Now, what we could think about is if somebody has a forward head position, meaning that their head sits, the center of mass is going to sit slightly forward and inferior, as if the person kind of slouches a little bit. They do that, so the new cervical spine posture is slightly forward relative to the trunk. Okay, and the effect of this is also going to be to draw the center of mass of the head anterior. So instead of being here, it's going to shift anterior and post and inferior. So then it will be somewhere, over here basically. And this is what we call effective flat slouch sitting or forward head posture. And now we have a new moment arm for the external load. And essentially that new moment arm is going to be longer than the previous one. So even though the weight of the head hasn't changed, the moment arm has changed significantly. And so let's see what this does to the posture the load on the back extensor muscles. So we have, here's our perpendicular distance, and a kind of a conservative projection is this may now be 12 centimeters. So if we recalculate then the external load, let's see what we get, right? So let's kind of go ahead and erase this one. Remember that we got, let's put the number up here. So we got 320 on the first run, newtons per centimeter. So it's normal posture. And then now we just have to change this number here to 12. Okay, and now our new calculation is 480 newtons per centimeter. So basically, what we can do now is kind of think about what's the difference in the load from a seated posture to a forward head posture. And if we kind of do this math, it's taking me a while here to erase this, but if we do the math, we can say this. So seated, like normal, is 320. So the increase due to the forward head posture is 320 minus 180, and that's going to give us a, what is that? That's 160, right? So 160 newtons per centimeter. And if you notice, 160 is half of 320. So the amount of increase relative to a normal or neutral sitting posture is a 50% increase. That's a lot. Okay, but if we look at a recent study, essentially that looked at the effect of changes in mechanical load and extensor muscle activity in the cervical thoracic spine induced by sitting posture modification, what's noted in this study is that people with a forward head posture have a 40% increase in neck muscle activity. And so essentially, just by focusing on the external load and noting that the external load increases by 50%, we have almost a match in terms of the amount of increased demand on the internal load, and say, for example, in the splenius capitis muscle.